We need to talk. We need to talk. I'll explain. Hi there. Are you happen to be one of the lucky owners of a 3D printer? Well, congratulations. I have one too. And there's something important we should talk about. Are you printing PLA most of the time? Yeah, me too. Sometimes PETG. Same here. But sometimes I also want to print high temperature materials like ABS, PA12 or ASA. Do you think about that as well? I even bought all of those materials already and I even tried printing them. But I always had a bit of a bad conscience while doing it. You might ask why? Let me explain. But before, I want you to know that there is a hidden sequence in this video. Let me know in the comments if you found it. So materials such as ABS, ASA and PA require much higher temperatures than PLA. PLA prints great at around 210 degrees Celsius, but ABS already needs about 250 degrees Celsius and PA12 can require 290 degrees and more. And even the chamber temperature can be raised up to 60 degrees Celsius, at least with my printer. And let me tell you, the hotter it gets, the more fumes are emitted. It for sure also depends on the material, not only on the temperatures. So ABS and ASA can emit styrene, which is known to be a human carcinogen. Nylon materials such as PA can emit caprolactam, I hope I pronounced it correctly, which can cause irritation to eyes and the respiratory system. So these emissions are called VOCs, volatile organic compounds, but that's not all. Most filaments also emit ultrafine particles, also called EFPS, and even PLA produces them. Now, don't get me wrong, I don't want to spread fear. I just want to raise awareness and say that we should be a little bit more careful when using 3D printers. And maybe I was looking for another project, I don't know. There's only one way of reducing toxic emissions. It's filtration. And there's only one way of getting rid of emissions totally. Ventilation. I'll get to both variants in a second. So my printer is located in the basement in my small workshop. There's a window there, but honestly, it doesn't really ventilate the room. My printer is enclosed and is also designed for high temperature materials. The enclosure seems to be sealed quite well, which means that most of the air leaves the printer through the fans in the back. These fans already have small boxes filled with activated carbon pellets, which are meant to filter the air while printing. The problem is though, there aren't many pellets inside. So early on I decided that I wanted to filter the air coming out of the printer. I built this filtration system for the back of the printer. So the idea is that the fumes coming out of the printer move upward and pass through 3 separate chambers filled with activated carbon pellets. After that, the air goes through HEPA filters. So this is actually the standard way of filtering polluted air. Activated carbon for gases and HEPA filters for particles. At least the rookie version. But there's a problem. If you filter the air and release it back into the room, it's very hard to know how much filtration material you actually need and how long it'll last before you become saturated. The same applies to HEPA filters. At some point, they will collect too many particles and need to be replaced or cleaned. And when you remove the filter, you might expose yourself to the particles again. Maybe it's depending on how clumsy you are. So that never really felt safe enough to me. As I said before, to be able to remove all particles and toxic fumes, you need to ventilate the air out. Filtration only gives you a certain amount of safety. So I had to find another solution. Especially because my kids sometimes come down to the workshop and the doors are occasionally open. That means that particles could escape into the rest of the house. I wanted to be able to print any material I want while still keeping a safe environment for my family. And since nothing is too much effort when it comes to family safety, this project might become a little crazy. I'm going to build a complete ventilation system, and actually not just for the 3D printer. I might have forgotten to mention this, but I also have a small gym down here. So the gym will get ventilation as well. And while I'm already building a ventilation system, I might as well add one for my garage to remove fumes when welding. And since my soldering station sits right next to the printer, we'll sit here eventually. It's not yet finished. This is another project, so I'm working on this as well. It would be pretty dumb not to have ventilation there as well. Right? 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 So yes, there are quite a few things to consider. And honestly, I may have gone a little bit too far with this project. But I promise it's going to be interesting, so stay with me. In this video, I'll show you the planned air path and the devices I'll need to design and build. The contaminated air will most likely leave the printer through the fans at the back. From there, it'll go upwards, then turn right and head towards the window. But stop! Before reaching the window, I need a valve somewhere here, so I can also extract fumes from other sources, for example my soldering iron. After that, the air will pass through the window and then go upwards outside. What you can see here, unfortunately, I will probably have to sell my old barbecue because it's standing right in the way. But that's a problem for another day, and for sure not for this video. So from there, the air will go up, then turn again, and run underneath the ceiling of my garage. At that point, there will be another valve which I can use to extract welding fumes, which can change between the air out of the basement or taking out the welding fumes. Finally, there will be the main extraction unit, basically a high volume ventilation fan that pulls the air through the entire system. From there, the air goes up through the roof and out into the atmosphere. So I've already designed the valve and it turned out much more complex than expected. And I really hope it's going to work. But that's for another video. If you liked the video, I would really appreciate a thumbs up, and if you don't want to miss the next parts of this project or other projects, consider subscribing to the channel. And I would love to hear from you throughout the comments what you think about the ventilation system and many other things. Thanks for watching, see you there.